Welcome to the DataStack Show. Today we are talking with Barr from Monte Carlo. She's one of the co-founders and CEO of the company, and they are in the data observability space. And Kostas, one of my questions that I hope we have time to get to is sort of the practical nature of what it takes to set up data observability in your company. I kind of think about, like, let's say you inherit a piece of software that you need to go back and write a bunch of tests for. I'm not an engineer, but I've been close enough to that to know that, that's kind of like, ooh, no one really wants that job. So I want to know, how hard is it to actually do this, right? Because we all have messy stacks, because we're trying to sort of build these things out as we go. So that's my question. How about you?
I think I'll spend some time with here on definitions, like trying to define like better what data quality is, what data reliability is, what's data observability is. I mean, we're using all these terms, and in many cases, we take the definitions for granted because they are mainly used metaphorically, coming like from other domains.
Mm-hmm.
It's a lot of always like exactly the same, right? Like it doesn't mean that's, an SLA for server availability is the same thing as for data availability, right? So I think she's the right person to have these conversations and try to understand a little bit better what all these terms mean.
All right, well, let's dig in and get some definitions.
Let's do it.
Welcome to the DataStack Show. We have wanted to talk to you actually for a long time, so what a treat to finally have you here with us.
It's great to be here. Thanks for having me.
Okay, so give us your brief background and kind of what led you to starting Monte Carlo.
Yeah, so let's see. I was born and raised in Israel, moved to California about 12 years ago, worked with data teams throughout my career. Most recently was at a company called Gainsight, where we worked with organizations to help them make sense of their customer data and basically improve their customer success and really create the customer success category. A large part of that was actually making that data driven. That was a huge shift in the category. Like before that, the world of sort of customer success was really built on pretty fluffy customer relationships, actually, kind of like you buy from me, I buy from you. And the introduction of subscriptions and recurring revenue actually forced organizations to think through, how do we make customers successful every single day? And oftentimes that actually requires data to do that well. And also, this was around like, the middle of last decade when it was easier to actually like ingest data and process data and analyze it. And so really sort of trying to become a data-driven organization was something that more and more companies were doing. And as I work with these organizations as VP operations, I noticed that, you sort of look at a company, there's like someone there that makes a decision like, let's get data-driven, whatever that means. And they're like, let's just like hire lots of data people and pour a lot of money into this and just really get data-driven for a second. And honestly, like those initiatives often fail. And I've found that the number one reason that those fails is because people actually don't trust the data. And so people, might look to making a decision about the data or actually using that data, surfacing it to customers, using it in production. When the data is wrong, people are like, well, why don't we just like resort to gut-based decision-making? This isn't really working for us. And it's incredibly hard for data teams to actually know that their data is accurate and reliable. So we actually started Monte Carlo, with the goal of, or sort of the mission of accelerating the world's adoption of data by eliminating what we call data downtime, which is basically periods of time when data is wrong or inaccurate. And a lot of the concepts that we use are actually concepts that have worked well for engineers. So we're not really sort of, reinventing the wheel in any way. We're actually taking concepts that work well in other spaces and bringing them over. So we started the company about 3 years ago. It's been incredible to see the data observability sort of category really accelerate. It's been, I feel incredibly fortunate to be sort of at the forefront of this and work with amazing customers who are pioneering this. We have folks like Vimeo and Affirm and Fox and CNN and Auth0 and really, really strong sort of data teams who are actually adopting sort of data observability as a best practice and a real part of the modern data stack.
Amazing. Okay. I have so many questions, and I know Kostas does too, but of course we do a little bit of LinkedIn stalking. And one of my favorite questions to ask is how previous experiences sort of influence the way that you approach what you're doing today, especially as a founder. So I noticed that you were involved in the military as a commander, which is fascinating. And so I just love to know, are there any parts of that experience that have influenced the way that you think about starting a company, running a company, and even solving the data observability problem?
For sure. So in Israel, military service is mandatory. And so everyone is drafted at age 18. Women typically do 2 years and men do 3 years. I actually originally wanted to be a pilot, but I was not accepted. And so as a result, I actually ended up being in an intelligence unit as part of the Israeli Air Force.
Wow.
So basically working on data intelligence that's related to operations as part of the Air Force units. Now, I was quite young at the time, joined, an 18 years old, and was promoted pretty quickly to be a commander, which meant that I was responsible for many other 18-year-old kids. You're joining the military without professional training, right? So you just finished high school, and especially without sort of domain expertise, right? And so you actually you don't have a college degree and you don't have sort of further degrees. And so
Wow.
you really have to learn on the job. There's no more on the job than that, right?
Sure.
And the second is it's also a lot of responsibility at a very young age. So I learned a ton. It's definitely like a reality check, right? You have a lot of responsibility. And as a commander, you're responsible for, your soldiers on different levels. You're responsible for their professional expertise, right? Making sure that they are the best at their job. You're also responsible for their physical well-being. And finally, you're also responsible for their mental well-being, right? For making sure that they are driven and motivated and excited about what they're doing, right? And that there's camaraderie. And so at a very young age, I was sort of thrown into this situation where, I really needed to create a cohesive team of folks with very little experience to do work that was very impactful and important, and to do it in a way that people can also thrive in it. And that was hard.
Wow.
So, I think I obviously learned a lot from that experience. I learned a lot about what people care and how to care about people, but also how to motivate them. But also honestly, about the power of bringing people who are really aligned on a mission. And even if you don't have all the experience in the world, and, even if you're not the world's greatest expert on this particular topic, you actually can learn on the job and you actually can make a big impact. And I think that gave me confidence later on, both to take on things that I wasn't necessarily the greatest expert on, and diving into something and being confident that we can bring something to the table. And also making bets on other people who are, perhaps earlier in their career, and helping set them up for success and making them shine. And that's one of the things that are most important to me in building Monte Carlo, is that, we're really proud of the journey that we're on, and we make Monte Carlo sort of a company that, can be life-changing for people.
That is incredible. Thank you so much for sharing. And you are building a great company. And so those lessons that you learned are clearly evident in the company and the team. Okay, I know I want Kostas to ask a bunch of questions here, but I'll kick it off. Let's talk about trust. So you mentioned trust. And we actually were talking with someone, a data engineer from a big mobile consumer company, and we asked what is the hardest problem that you've ever had to solve, as a data engineer. And it was fascinating because he paused for a second, he kind of stared off camera, and you could tell he was thinking really hard. And his answer was trust. He said, that's the hardest problem that I face every day, right? So my question for you, and would love to just hear your sort of thinking on this, even philosophically, as you're building Monte Carlo, how much of that is a technical problem and how much of that is a human problem, right? Because there are certainly technical aspects to it, to your point, adopting principles from software engineering, there's testing, there's all sorts of stuff, right? but trust is a very visceral human experience, right? So I just love to hear how you think about that.
Oh man, that's a great question. So first of all, I love that you asked that, because that's actually what I've experienced before starting Monte Carlo. So just to give the context a little bit for how we started the company, I actually started 3 companies in parallel when I started Monte Carlo to actually explore like what does product market fit look like or doesn't look like. And so I actually read this book. It's called The Mom Test. It's a pretty bad title, but the book is quite good. Which I don't know if you had a chance to read it.
I haven't read it, but I've heard of it. And the title is like so hilarious.
Yeah.
What?
Yeah. And basically it gives good guidelines to help think about how to have conversations with customers early on. And the idea is basically there are people who, if you would share an idea with them, they would give you positive feedback on that idea no matter what. And you have to find the people who would give you real feedback. Those are often folks who actually like don't care about you or what you're doing.
Yep.
And that's contrary to most ways in which startups get started today, which is like going to your network. And so actually what I did is reached out to like hundreds of people who knew nothing about me, who owed me nothing, who were data engineers, perhaps like the person that you spoke with. And I just asked them like, what's keeping you up at night? Like, what's your biggest nightmare? What's some like shit that's like annoying you these days?
Totally.
And their reaction was so visceral to this thing around data trust. People were like, I wake up sweating at night because there's a report that my CMO is going to look at tomorrow morning, and I'm not sure that the numbers are going to be accurate and everything is going to work out. Like people, or I remember a chief data officer of a public company told me, last week we nearly reported the wrong numbers to Wall Street. Like we caught it 24 hours before. It was someone on my team, like not even me, someone on my team caught the issue 24 hours. Like that is sort of implications for your, for your job, right? For your professional integrity, it goes on to so many levels. And so I similarly, starting the company saw that, right? That like people are just really sort of visceral about this. It's kind of ironic given that data, you're like, you had one job, just get the numbers out.
Sure.
But it's freaking hard. And I experienced that myself as well. So I was leading data analytics team and like the numbers were wrong all the time. And I would get like WTF emails from like my CEO and others are like, what's going on? And so, first I'll say like, I think the kind of importance of this problem is that it's not just, getting the data right. It's also like tied deeply to people's kind of pride, professional pride, and sort of satisfaction in their job as well. And I think that's why it's even more important to solve it. So, specific to your question on like, how do you go about thinking about a solution like this? It's definitely a combination of tech and people, right? On the tech side, I think there's changes in the last couple of years that have made it possible for a company like Monte Carlo to create a standard solution. So the rise of data warehouses and BIs, and honestly, a standardization around a finite set of solutions that a typical company will use has allowed us to build a finite set of integrations, right? So Monte Carlo today can we support all data warehouses like Redshift, BigQuery, Snowflake, all BI solutions, Tableau, Looker, Sisense, Mode, and data lakes, starting to support that as well. And also ETL solutions, like and orchestrators like Airflow and DBT. And because of there's sort of this rise of, like quote, there should be like a buzzword alert on the podcast right now.
I love it.
Buzzword alert, the modern data stack. Exactly. Thank you. So with the rise of that, it's basically like sort of a consolidation or kind of an agreement or what are like the top vendors that folks work with, right? And that actually allows standardization in terms of how do you think about pulling metadata across those stacks and how to think about like what we call the pillars of data observability, which we've sort of codified as a framework to think about common shared metrics for how to think about data observability. So, I'll explain a little bit here. what does data observability mean? It really is a corollary to observability in software engineering. And software engineering, it's very well understood what you would measure, right? So if you use AppDynamics or New Relic or Datadog or whatnot, you look at specific metrics, or engineering looks at specific metrics to make sure that you have 5 nines of availability. Now let's look at data organizations. You have people like data engineers, data analysts, data scientists who are working to create data products. And those data products can be dashboards or machine learning models or tables or data sets in production. And they need to make sure that those data products are reliable. But how do you measure that? Whatever you use in software engineering does not translate. And so we actually had to codify what that means and sort of build around that. And so, when we think about, the tech part, there's definitely kind of advancement that have allowed that. And when you think about the people part, it's definitely the rise of what I would call sort of the data engineer role in particular, because that person is now responsible not only for the job to be completed, but for the job to be completed, the data to be accurate, the data to be on time, sort of everything else that actually encapsulates what we would call sort of trusted data.
Barr, I have quite a few questions around that. So we'll have the opportunity to get much deeper into observability. But before that, I have a very cliche question to make first, which is why Monte Carlo? Why did you choose this name for the company?
That's a great question.
That is a great question. We are big Formula One fans at Monte Carlo. I'm actually wearing a Formula One hat, but that's actually not the reason. But so, when we started the company, one of our principles at Monte Carlo is to build something that solves a real customer problem versus building something that we don't know if anyone will actually use. And so we actually got to a place where, before starting the company, spoke to a couple hundred of people from data organizations, asking them about what their problems are. We actually got to a point where we very quickly wanted to start working with customers. And so I actually had 24 hours or something crazy like that to choose a name. And, I was like, okay, we'll just choose something for now and figure it out later. And I studied math and stats in college. So I literally opened my stats book, who I have right here actually, and, riffed through, and the options were Bayes' theorem, which did not seem to be great. The next option was Markov chains, which seemed even worse for a company's name. And the third was Monte Carlo. And I was like, oh, Monte Carlo, I can work with that actually. It's something that is both approachable, people know about it, but also has its sort of roots in data, if you will. Yeah. And so it's named after the simulation in that sense.
Okay, that's very interesting. I really like the bridge between the racing there in Monte Carlo and the statistical method. All right, cool. So as you were talking about data and data quality and observability, you mentioned a couple of terms, and 2 of them is data has to be accurate and has to be reliable, right? So I mean, it makes total sense, right? I don't think that anyone's going to argue against that, but many times we forget to be a little bit more of engineers, let's say, and try to be a little bit more accurate on this term. So what does it mean to be accurate and reliable when it comes to data?
Great question. So I think what you're saying is spot on in terms of let's introduce more diligence to what it means to get trusted data. And I think the path to that is actually operationalizing what that means. So let me get a little bit more specific. When we think about, we sort of call this the data reliability lifecycle, there's sort of 3 core components to it that help us, or what we've seen is that our customers, if they actually operationalize with these 3 sort of parts, that helps them generate trust. So there's 3 core components to it. The first is detection, the second is resolution, and the third is prevention. So I'll double click into each of those for a second. And by the way, just to clarify, each of these stages is introducing tech, but also processes, SLAs, contracts between teams, ownership, clarifying sort of who's responsible, who's accountable, et cetera. So on the detection side, actually understanding when data breaks and understanding why it breaks, or understanding the impact of it. So let's sort of define how we actually do that. I sort of talked before about how in observability and engineering, it's really clear what you're measuring. It's not as clear in data. So what we did is sort of from all the conversations that we had with companies, ranging from large organizations like Facebook and Uber and Google who built this in-house to small startups who didn't, we basically codified like all the reasons for why data breaks and all the symptoms for it and all the different things that people do to deal with it. And we've come up with these 5 pillars that we think together help bring sort of that holistic picture. So the first is freshness of the data. So there's different ways to look at it, but basically, I'll give you an example. If there's a particular table that gets updated 3 times an hour for the last week, and today it hasn't gotten updated yet for the last 3 hours, that is a freshness problem that can potentially indicate about some problem with your data. There's different ways to look at freshness, right? You can look at timestamps, you can look at volume of the data. Actually, there's different ways to measure freshness, but basically like, is the data arriving on time? The second concept is volume. So literally like, again, pretty straightforward, but like you can look at the number of rows over time and say like, okay, the number of rows has grown 5% every single day for the last week. Today it suddenly dropped by 30%. What's going on? Did we miss something? So maybe the job was completed, but data actually wasn't transferred, for example. So there's a second around volume. The third is around distribution. So distribution is sort of like a catch-all phrase for changes at the field level. So for example, if this is like a credit card field and you're expecting numbers and then suddenly you get letters in that field, for example, or if you have shoe sizes and it's suddenly like, I don't know, shoe size of 100 or something. That's obviously like, doesn't make sense. You can look at percentage null values, percentage negative values, etc. The fourth is schema changes. So actually schema changes is it's like a common culprit for data going wrong. And so oftentimes like an engineer might make a change somewhere that will result in a field type changing or in a table added or removed, and everyone downstream is not aware of that. So automatically tracking all changes to tables, to fields that are being added, removed, or edited. That's a fourth pillar. And then the fifth pillar is lineage. And so we actually just released a great blog about how we built field level lineage. And when I say lineage, I mean both table level and field level lineage. And actually being able to automatically reconstruct your lineage without any manual input, just by connecting to your data warehouse and your data lake and your BI, and actually understanding like the connections between tables and fields and overlaying data health on top of that is incredibly powerful. So being able to say, someone made a change somewhere upstream and that resulted in this table downstream that now is not having the data up, is now, doesn't have the right data, and resulting in this report downstream that now has like, a higher percentage than what you expect null rates. Having that view is sort of the start of what we call this like detection phase. Does that make sense? I'll just pause there.
Oh, absolutely. Absolutely. I love the way that you have codified this, to be honest. But I have like a follow-up question to that. Like, the way that you describe makes like total sense, okay? Like from my at least experience so far. But how much can be done with standardization, right? And how much we need to account for the business context that this data operates in to make this framework work? Or we can completely automate it. Like, what's your experience so far on that?
Great question. So what we see typically is that most companies today try to do a lot of this stuff manually with tests that they would write. And so, 80% of issues actually go uncatched or unnoticed, meaning they hear about it from someone downstream. So let's say, for example, my CMO or my data scientist or someone that I'm working with is like, hey, like ping on Slack, why is the data wrong? What's something here is off? Help. It's probably your fault. Go figure it out. Kind of like not fun notes on Slack. And so 80% is caught in that way, and 20% is caught with sort of manual kind of tests or manual checks that you could write based on business knowledge. What we think in sort of a better world, and what we're seeing with our customers and other sort of strong data teams who are implementing this, is that actually with standardization and automation, you can catch 80% of the issues. That's the reality of what we're seeing. Like, I think everyone really thinks that they're a snowflake and everyone thinks that they're unique. Yes, it's true. They are snowflakes. And you can also automate a lot of that stuff. Again, thanks to standardization in the modern data stack, right? And so I think what we're seeing is that 80% of the issues can be caught with automation. And then there's probably like 10 to 15% where only you would know, like no automation in the world can actually catch that. And so that like 10 to 15% is one where like really the unique expertise of data engineers and data analysts should actually spend time figuring out, like, for example, our customers view this data every Monday at 6 a.m. So at 5:55, this better be accurate. Or for example, this field in our business doesn't make sense to be higher or lower than 100, for example. Like, let's say, I have a ticker value, for example. Like there's some, sort of some use case in particular where only the business would understand that. And so, but that is only like the 10 to 15%. It doesn't make sense for those teams to spend their entire time actually building that. And then, hopefully there's like 1 or maybe 2% that's like caught by things that just went unnoticed and would be caught by our customers, by your sort of like downstream consumers. And so I would say like expertise and domain know-how is very, very important, but I feel like we can make better use of that so that data engineering teams don't spend their entire time building this, start with something off the shelf, and then can add their knowledge sort of in a more custom directed way, if that makes sense.
Yeah, 100%. Yeah, I totally agree. And okay, so far we had data to work with, right? A lot of data, actually. One of the biggest problems that we have is that like we have way too many data sometimes. And now we also generate data about the data, so we can monitor the data, right? So how do we deal with that? Like, what kind of like experience what kind of experiences we need to build as like product people or like companies or vendors in this space to make sure that like at the end we don't cause more frustration to our users, but we actually like help them figure out what's going on with their data.
Yeah, I sort of referred to there's like this big like hoarding of data, and now there's this like big hoarding of metadata, and you're like, that was useless. This is going to be useless too, but we're just going to do it because that's what people do. It was just like the hoard data. I'll also say something controversial. I think, metadata by itself is quite useless. Lineage by itself is quite useless. Like nobody gives a shit about that. It doesn't matter, right? It's like great eye candy and you're like, oh, yay, like I have lineage. But where is it actually useful? What we're seeing is that metadata and, or things like metadata and lineage can help and be particularly useful when they're applied to a specific problem. So for example, I sort of talked about this data reliability cycle of detection, resolution, prevention. In the detection phase, if something breaks, like if some table breaks, but nobody's actually using that table, like there's no downstream dependencies on that, and no one is querying that, maybe I don't care about that particular table, right? Maybe actually I don't need to know that the data is inaccurate there. It can be inaccurate and like, who cares, right? On the other hand, if there's a particular table that the data is inaccurate, there's 300,000 downstream nodes that are connected to it. There are 10 reports that my CEO and my top executives and all of my customers are using on a daily basis. Yeah, I better get that data right. So actually using that context can help inform that and make it better. And similarly, we see that throughout this sort of life cycle. So in the second part of resolution, which is basically like, how do you speed up, moving from being the first to know about data issues, moving to being very fast and quick and actually identifying the resolution of data issues. That's where these things can also help us give us clues to, okay, a table here is broke, and at the same time, there was a change in this field, or these 3 other tables also broke at the same time. And this is related to a change that a particular user in the marketing team made, for example, around the same time. So we can use all that information together to actually speed up resolution of data incidents. We find that data engineers and data analysts and data scientists spend oftentimes between 40 to 80% of their time on data fire drills. And so if you can use all that stuff in context with this, it's actually really powerful. And then the third part of like prevention, we're actually finding that, people have reported sort of north of 70 to 80% of their data downtime incidents reduced once they have more access to this context that metadata and a lot of other metadata and data together can combine. So for example, if we have like a report on like deteriorating queries that can give us really insight into like where there are specific problems in our infrastructure, that can help us give clues as to how do we build a more robust infrastructure overall that can reduce data downtime incidents. So being more proactive about how we manage our metadata and our data, I think also helps us make sure that it's more robust and trusted at the end of the day.
Yeah, 100%. Okay, so we talked about detection a lot. The next step is resolution, right? So what does resolution mean?
Yeah, so resolution, great question, means moving from the world today in which it often takes weeks, sometimes months. I haven't seen a case of years, but I might have to go back to my notes, but literally very long periods of time that it takes to identify the problem, do a root cause analysis, and fix the data, right? And shortening that time significantly, right? Also thinking about SLAs for that, right? So like how quickly are those issues have to be resolved and for what severity, right? P0, P1, 2, 3, different issues, we should have different agreements on that. And so actually having SLAs and contracts with your data team on different data sets. So one thing that we're seeing is thinking of as part of this movement of like buzzword alert, data as a product, there is, thinking about sort of different domains, right? And sort of domain specific ownership. And so you can have like specific data sets and pipelines that are, sort of mostly used by the marketing team, for example. And maybe the SLAs there are different than the SLAs for data that's used by the finance team or the finance domain. And actually, like, maybe finance uses the data like once a quarter to report to Wall Street. So, you have more time, but maybe marketing, it's actually feeding, like a pricing algorithm for pricing houses in a particular market. And so, if you're underpricing or overpricing a house, there's a big difference there, for example. And so, or just to give another example, one of our customers, Vimeo, it's a video hosting platform. They have a very strong team, and they actually have used data in the pandemic to not only sort of sustain their growth, but even fuel it. They've done that by sort of identifying new areas of sort of revenue and opening new revenue channels for them. And a lot of that has been enabled by introducing data observability concepts of sort of detection, resolution, and prevention across the business. So for them, they use real-time data to basically make a decision on like how much bandwidth does a particular user need, for example. And so the SLAs on that kind of data is obviously very, very different than the others. And so, thinking about resolution, you sort of think about kind of impact radius, right? So who's actually impacted by this? And then also sort of downstream, then also upstream, how do you actually locate the particular problem? And sometimes a problem, can go sort of beyond particular data warehouse and can be part of sort of, you can kind of use like logs from sort of DET or Airflow or sort of other orchestrators to help sort of pinpoint that. But generally, I don't think that necessarily resolution is about like automatically identifying the problem and solving it for you as a platform, but rather giving data engineers the tools and the information to identify the problem way faster. Kind of like in the same way that you would use New Relic or Splunk to identify a problem on the infrastructure or application side.
Yeah, 100%. Okay, I need your help to understand a little bit better, like the concept of SLAs, right? So, I mean, I love like using metaphors in general because it helps a lot to help people like understand what we are building, especially when we are talking about a new category like data observability here. But the problem that I have is that like an SLA, when it comes to infrastructures, like it's a very, very specific thing that has to do with the availability, right? Like we measure like how much time a service or a server or whatever is available like to use, right? Now with data, things are like a little bit more complicated there, right? And the problem there is that you might even have like edge cases where the data, because something went wrong, does not even exist, right? Like, let's take, for example, how RudderStack is used, right? Like we have a developer, an SDK is integrated on a website, for example. If the developer does not capture correctly an event, let's say instead of sending the actual values and just nulls there, like the data that like was never captured, right? So what does it mean to set an SLA there? Or how do we communicate also like these kind of problems that might exist with data and that we don't have with observability when it comes to infrastructure, right?
Yeah, such a great question. And, I can give my 2 cents from what I see our customers do, but, just to be honest and transparent, these are early days of the category, right? So we are defining this sort of as we go. And I think for data teams, more and more teams are doing this, but it is still early days. Like, I remember actually Facebook did or Meta, sorry, did an observability summit a few weeks ago. And we're talking about, I think, that they have a very high number of sort of tests that they have and starting to introduce SLAs, but actually some of the concept that they were really sort of interested in is how do you think about data downtime and how do you measure data downtime? That's a very vague concept. How do you actually do that, right? And so one definition that we sort of introduced is a combination of 3 metrics. One is number of incidents that you had. The second is time to detection, like your average or median time to detection. And the third is time to resolution. Mm-hmm. And so like measuring data downtime as dependent on those 3 measures. Now, I can introduce that concept all day long, but most teams actually don't even measure time to detection, time to resolution yet. And so you're right, in order to introduce things like SLAs, there needs to be a baseline that's established. And I think that's where we're at these days with establishing those baselines. Now, particularly in the example that you shared, you could, or an example of an SLA can be this particular table gets updated every 3 hours, and we can only accept a deviance of X hours, or we need it to be, on time 99.99% of the time, for example. So that's like a very, very specific kind of SLA definition for a specific table that we know that like this needs to be updated on a regular cadence. So that's like an example for a freshness problem, freshness SLA, for example. But I totally agree with you. This is like very, very early days. And, I'm happy to share, actually, there's like a blog that we wrote with an example of like an SLA dashboard that you can actually get an example of Calibri Games, I believe, actually, that has specific SLAs from how often and how regularly they get their marketing data from third-party vendors like Facebook, for example. And so they have particular agreements on how often that data is received, and contracts between teams on when they can actually use that, when they can rely on that. So I'm happy to sort of share that as an example for something that's like put in practice. But I agree with you. It's early days, and we're seeing a lot of innovation. So I'm excited about where we're going with this. But I can tell you that I've seen a data team that like operates with 100% data uptime on all 5 pillars. And they're like, our data is perfect, don't talk to us. Like I've just never seen anything like that.
Yeah, absolutely. And I think that's like one of the differences that we are going to see with SLAs in this industry, like compared to the infrastructure observabilities, that, okay, data is not like a server. It's not like a binary thing. It exists or it doesn't exist. I mean, it runs or it doesn't run, right? So I think when we are going to like get to a point where we understand SLAs better, there are going to be like much more dimensions that we measure there. And I think that it's going back to the beginning of the conversation, and it has to do more with trust, like trying to measure like how much I can trust at the end this data set that I have, and not that much about is the data set available or not available, or like these kind of things. Awesome, like that was like super interesting, and thank you so much. You really helped me like understand better like the concept of SLAs. One last question from me, and then I'll give the stage to Eric, because I monopolized the conversation. And this time I want to ask you something that has to do more with building a company and not that much about data and data observability. So you are one of these like quite rare cases of people who decided to start a company while a new category was under formation, and you are at the forefront of that, right? what does that mean? And what are, let's say, the fun part of doing this, like trying to build a company while the category is not yet there? And what sucks?
Great question. So in general, I would say, it's funny, you know, when you start a company, kind of everything is really hard. Like nothing is easy, right? So what's I always remind myself what's the percentage of startups that fail? I think it's like 99.9% startups that fail. And so you're by definition embarking on a journey that you know has like very likely to fail.
Yeah.
And yet you are getting started, right? There's just something very weird about that. Like,
there's something wrong with these people. I know. I am one of them.
Exactly. You're by definition like, why am I doing something that is basically doomed to fail, right? And so you develop different ways to think about the world, right? One of the things that helped me get conviction early on, you know, that's why I sort of mentioned I actually started 3 different companies. I was like, look, if I'm going to get off of my cushy job and get other people to like leave their cushy job, it better be an idea that I have a lot of conviction on and I'm really excited about. And so I spent a lot of time before actually starting the company with customers and with their pain. And that gave me a lot of conviction about this. Now, you know, when you sort of start a category, it really it sort of makes the existence of the company hinge on the category creation. And I remember I was chatting with, I think this is Lloyd Tabb, one of the founders of Looker. And he's like, look, the worst thing that can happen to startup early days is that like nobody cares, just nobody gives a shit about it or about the category. And so it's way better to have like either like some strong reaction, either love or hate, but some strong reactions. And so we spent a lot of time on category creation at the very, very first days of the company. So actually one of the first few things was that, you know, I wrote a blog post about data downtime, about my experiences. And I remember this was before we actually incorporated the company. I was curious whether the concept of data downtime is something that anybody cares about. And so I actually applied to a conference, Data Council actually, and with like the title of data downtime. And, you know, this was before there was a product or anything like that. And I was like, let's see what happens. And I assumed, you know, only 4 people would show up and it would be kind of awkward and I'll kind of like hang out with them and talk about, you know, some random things. And then we'll just move on with our lives and pretend like they didn't happen. And actually there were like, I don't know, more than 100 people showed up. And after the talk, they were like, thank you for giving us language for this. And we feel like this is the beginning of a movement. And this was literally like, it was just me. I didn't have, you know, I wasn't with my co-founder yet and there wasn't anyone else, but, you know, that gave me the sense that like, okay, we're working on something that people care about. And we need to like actively invest in it all the time. So I would say like, you know, the fun parts are that you're working on something that's like really important to people. And you're solving like real customer problems. Like, you know, 100% of our customers renewed at Monte Carlo with us this past year. And so many of them are actually like, it's because we've been able to make a positive impact on their lives. And that's, you know, the stuff that I'm really excited about. Like we're actually doing something that people really care about. You know, I think the hard thing about it is that it's hard, right? We're not competing against, you know, 10 other options for customers. We're actually educating our customers on, you know, the fact that there's a problem they're very well aware of, but there's a lot of education on like, hey, there's actually a different way to think about this problem, right? So our customers live in a world where they might have to manually look at reports all the time to make sure that the data is accurate. And now, you know, we're introducing a world where you can actually sort of rely on sort of an alert to tell you that something is wrong versus having to like manually check that. And there's also an education of saying, hey, look, there's concepts in observability and software engineering that worked. They can also work in data. Like there's a lot of engineering best practices that we can bring over. And that is the education part. So we invest a lot in it. Like we write a lot, you know, we spend a lot of time with our customers on it. We really see it as like an existential part of the company.
Yeah, 100%. And I think that like the mechanism of metaphors are like something very, very important in category creation in general. That's why I ask also about the SLAs and all these things. Anyway, we can be like discussing about that stuff for like 4 hours. But Eric, all yours.
All right. I think we have time for one more question. And Barr, I'd love to actually get practical here. So in an ideal world, you can have this experience of like, let's say building software from scratch, with all of these principles like unit testing and, all this sort of stuff, which is like, it's cathartic to think about that, I think, for all of us, just because, cleaning up messes is really hard, right? But the reality for most companies running, sort of even a stack that has a moderate level of complexity, which I would say is most companies who, buzzword alert, like are trying to do something related to the modern data stack. Like when you think about observability, you're often coming into an environment that, not because anyone made really bad decisions, but especially as companies are just growing quickly. I mean, even thinking about reacting to COVID, all of the data and everything there, you're dealing with a situation where there's a lot of complexity. There were a lot of things that it would have been great, if you had done them, when you were initially building the stack, but you didn't because you're moving too fast, or you didn't have enough resources, or there's new technology coming in, et cetera. So could you help our listeners understand, it would be so great to just do observability from the ground up and have it, integrated into every piece of what you're doing, but that's not the world that anyone lives in. So practically, like when you go into a customer and you're implementing Monte Carlo, what's the lift? I'm thinking about the data engineers, maybe even heads of data, who are just kind of like, that sounds so nice, but like, ooh, I don't know if I have like literally the resources to do like a 6-month project and, all this sort of stuff. So like, what does it look like? How hard is it? How long does it take? Like, what's a lift? How many people, et cetera?
For sure. By the way, I don't think I've ever seen, for the record, I don't think I've seen a customer who's like literally has like the perfect, or even like a clean, great standard, right, or setup, right? Like most folks, I don't know, 99% have like a lot of debt, a lot of people who have like come and gone, a lot of questions
Sure.
if they have, a lot of complexity, right? So I think that's actually the reality for like most everyone. At Monte Carlo particularly, having been in the shoes of teams that we work with, we recognize how little time they have and how unrealistic it is to spend 6 months to do something like that. And so actually early on in the company building, we've invested a lot in making it incredibly easy to get started with Monte Carlo. And so if you have sort of a standard stack, which I would say like, Redshift, BigQuery, Snowflake, Looker, Tableau, et cetera, you can actually get started in less than 30 minutes.
Oh, wow.
So less than 30 minutes. And those 5 pillars that I talked about, you get that out of the box. So within 24 hours, you actually have table and field level lineage. And within our models start working, and within a couple of weeks, you will start having detection, resolution, and prevention sort of features working for you. You can add customization on top of that for your own, but those 5 pillars are automatically out of the box within that 30-minute onboarding. No other sort of integration work required.
Wow, that's amazing. So pretty low lift, I would say, and then you can get into customization. And then just trying to help our audience understand like what this dynamic looks like inside of organizations. Who are the users, or who's the primary user of Monte Carlo, and how do they interact with the product? And like, what does that cadence look like as part of their workflow?
Yeah, so users are sort of data teams. And so most typically data engineering, data analysts, sometimes data scientists as well. I would say that titles are a little bit murky these days.
Sure.
Right. It depends a little bit on like who are the people who are actually sort of responsible for the data being accurate. Those 3 titles are the ones that we see the most. I would say more data engineers and data analysts. And then in terms of like, what does it actually look like? Folks are, kind of incorporating it more and more into their workflows. And so that might mean like waking up in the morning and like, checking to see whether like the status of the data is up to date. And then, throughout the day, like, I want to make a change somewhere and I want to understand if I'm going to change someone's workflow because of it. And so I might go in and see, okay, if I'm making a change to this field or particular table, who's downstream actually like dependent on this and that, would need to know. So I'll be thoughtful about that change. And then, maybe later in the afternoon, I get sort of, an alert about a particular problem in the data. And then I might sort of double click into it and understand like who's impacted, what are the queries, et cetera, and kind of doing research to understand what actually happened. So it's mostly sort of embedded into folks' sort of day to day, if you will. And largely, it's because folks end up spending a lot of time on data fire drills. And so the goal is to reduce that amount of time, basically.
Yep. Okay, one last question. I said we had time for one more, but I've asked three. So I love that you talk so much about interacting with customers, talking with customers. So you're really close to these data teams. So really quickly, I just want to know, what's your favorite part about working with data teams? You've worked with so many different teams over your career, but what do you love in particular about working with data teams?
That's the favorite part of my job. Literally, that's like what gets me out of bed in the morning is, to sort of hear the amazing stories of data teams. I think maybe the favorite part is like how powerful data is. We work with companies like Fox, for example, that, covers events like the Super Bowl, and they literally track like, number of users and time spent on content and devices, and like literally powering such important events. And, then we have customers in healthcare that use data for diagnostics, and just like the use cases are so wide, even more so like in, with COVID-19 and everything, it's become even more important. It's just inspiring what data teams are actually working on. It's pretty freaking cool. It makes me really proud to be working with them.
Awesome. Well, thank you again so much for giving us some of your time. Wonderful conversation. And we loved having you on the show.
Thank you so much for having me.
Thank you, Barr.
Okay, Kostas, this is something that I've thought about a lot over the years. And I don't know why I've thought about this, but when you think about technology, and maybe this just comes from me doing a lot of consulting, but I was like, okay, there's probably like 10 business models, across B2B and B2C that you could build basically sort of a predefined like data schema and stack for, and it would work for like 90% of the companies out there, right? Like a lot of times the customizations are not necessarily a good thing, even though each business is unique, right? And it was so interesting to me to hear Barr, to some extent validate that, right? Like we probably can solve 80% of the data problems because they're fairly known quantities. And some of that has to do with the tooling and, other stuff like that. But it was just really interesting to hear her talk with such a high level of confidence and say, look, yeah, every business is unique, but really only 10 to 15% of the problems are, of the nature where it needs like, sort of customized resources, and we can automate the rest of it. That was really cool to see her talk with such confidence about that.
Yeah, 100%. I totally agree with you. It was very
and validate my idea, of course.
Yeah, I totally agree. I mean, it was very interesting to hear from someone like her, like talking about standardization and how standardization like should be part of the product that we offer. Like standardization is usually, mentioned a lot by engineers, but in a more, let's say, like kind of academic context, usually we don't really consider it as part of like building a business, but it is important. And I think it's even more important when we are trying to build like a new category, as like Barr is doing right now with the rest of the vendors like in this space. So people need guidance, people need education, and standardizing processes and concepts is one of the best tools you have like to do that. So yeah, like I love that part, and the whole conversation was amazing, and hopefully we're going to have you back again and discuss even more about all these concepts.
I agree. Well, thanks for joining us again, and we will catch you on the next show.